Welcome to this videotape about Boxer, a new computational system being developed at MIT's Lab for Computer Science. One of the major goals behind Boxer is integration, to provide a single uniform system that embodies many typical computer functions. When people think of using a computer as a personal tool, they might have a variety of projects in mind. They might want to use the machine for word processing, or computer mail, or to do calculations, or to work with graphic images, or for any number of reasons. The problem is how to make a coherent system that people can adapt to do all these things in a simple and natural way. Boxer is designed to meet this need. It's a programming environment, but it's designed so that many applications can be created with little or no programming, and so that anyone can tailor these applications to their own individual preferences. In fact, we hope that Boxer will help change the meaning of programming from a difficult activity done by experts to something that people do all the time to personalize the computational tools that they use. In this video, we're going to explain some of the basics of the Boxer system, and we'll demonstrate some customized environments that a person might create using Boxer. Our prototype Boxer system is implemented on a Lisp machine, a high-performance personal computer. The user can provide input to the machine by typing at the keyboard, or in many cases by using the mouse, a pointing device that controls the arrow on the computer screen. The journal shown here is one example of a personal information system that a person can implement on their own using Boxer, with very little or no programming. Here are some entries in a journal. Each entry is a box on the screen. If we have a box on the screen, we can shrink it to hide its details or expand it to look at its contents. We can add or delete things inside the box simply by moving into the box and typing. Notice that the box adjusts its size to accommodate the text being typed into it. We can also create boxes inside of boxes. In fact, all the entries taken together form a box called chronology. Box structures are the most common means in Boxer for grouping things, not only for this journal example, but for all kinds of data and programs. There are a few basic mechanisms for manipulating boxes, like shrinking and expanding, creating them, moving them around, and giving them names. These operations are built into the Boxer system and are part of every environment we create. Our journal also includes a few special purpose operations, which are actually simple programs written in the Boxer programming language. The first operation makes a new journal entry. We can get a new entry by typing entry, like this, and hitting the do it key. Now we can type into the template, filling in as much as we want. The second operation files the entry. It's called file. This inserts the entry into the chronology box. One of the advantages of a computer-based journal over the pencil and paper kind is that we can organize the same information in more than one way. In this journal, we can look at the entries in chronological order, as we've been doing, or we can look at them organized by topic. The entire journal actually consists of two boxes, a chronology box and a topic box. Let's expand the topics box. Here we have the same entries as in the chronology box, except organized by topic. These really are the same entries. As we type an entry into the topic box, the view in the chronology box automatically changes. Keeping the two views synchronized is accomplished automatically in Boxer by a mechanism called a port. A port is a view of a box at some other place on the screen. The file command that we used before created a port in our new entry and placed it in the topics box. Ports are Boxer's general method of sharing. They can be used in systems like this one to provide alternate organizations of the same data. The journal we've just seen illustrates some of the basic features of Boxer. The idea that we can organize data into boxes, that we can manipulate boxes or change their contents, and that we can run programs. Let's look at these same ideas in a more elaborate example. This is a Boxer environment called Learn, designed to teach new users about the Boxer programming environment. Learn is arranged as a kind of video book. When we expand the Learn box to look inside, we see boxes dealing with various topics. The shrunken boxes act as a table of contents. If we expand one of them, we can see subtopics. These early chapters of Learn teach the users some of the basic operations we saw earlier. How to move around the Boxer screen using the mouse, how to create boxes, and how to name them. Let's go into the programming box and look at a simple numeric program. Here we have two numbers called A and B and a formula that computes the square root of A plus B. If we run the command formula, Boxer shows us the value returned. Here A is 4 and B is 5, so the answer is 3. We can change the value of A and B and run the program again. Let's change A to 10 and B to 20. We can make a new box called C and run a command that makes C the result of applying the formula. Notice how C changes automatically as we run the command. A, B, and C here are variables in the Boxer programming language. Variables are always shown concretely as boxes on the screen. To change a variable, we can simply edit what is shown on the screen. And if a program changes the value of a variable, the value on the screen is updated automatically. This treatment of variables is an example of a general underlying principle of Boxer, which we call concreteness. The state of a computational system is what is shown on the screen. This implies that in order to change something, like the value of a variable or the definition of a program, you need only to edit what is shown on the screen without having to run any special kind of update program. This kind of concreteness is typical of many contemporary application programs, such as spreadsheets and database systems, and is a major feature in making such programs easy to use. In the Boxer programming language, concreteness appears throughout all applications in a uniform way. Consequently, a person who wants to implement a spreadsheet or a database program in Boxer will find that much of the task of updating the screen and getting the information will be supplied automatically by the Boxer system. It will not require any additional programming.
Now let's look at how we might build up a new Boxer environment from scratch. This will be a simple special-purpose calculator for computing the total and average of a set of scores. The user will enter the scores one at a time, and the system will show the running total and average. We begin with boxes that will hold the total of the scores, the number of scores, and the average of those scores. The score box is where the user will type the scores. we can write a program to perform the computation. The new total is the old total plus the score. So the first line in the program says to change total to this new value. The number of scores is increased by 1. The average is the total divided by the number. We will give this program the special name square key. This special name means that the program will be run whenever we press the square key on the keyboard. Now we can use our calculator by entering the scores in the scores box and pressing the square key. Each time we run the program, we see the new total and average. Here is a fancier version of the calculator that keeps a running histogram of the scores. The histogram is an example of a graphics box, which is a kind of box used for holding pictures. Graphics boxes can be manipulated, shrunken, expanded, and named just like other boxes. Our next example of a boxer environment is a more elaborate version of the calculator idea. The boxes with number labels act like calculator buttons. By using the mouse to select these boxes, we can make the appropriate number appear in the calculator window. Typing a Do It key executes the operation shown in the window. The answer appears in a special box. There are also a variety of special purpose keys. For example, a cosine key. And depending on which keys we want to use, we can format the screen in any way that we wish. For instance, if we're going to do a lot of calculations which will need the cosine key, we can bring that key out of the special purpose box and use it, and put it back when we're done. This screen calculator also has keys for solving systems of equations. This box contains some equations, and this one contains variables to plug into the equations. Here, the value of A is 10, but B and C are unknown. Now, by pressing a key, we can solve the equations, and the variable boxes are changed to reflect their correct values. Boxer's power lies in a small set of simple general ideas that form the core of all customized environments. Ideas like storing and displaying information in boxes. Because Boxer's totally integrated, these ideas can be combined in creative ways to serve any particular purpose. Text and running programs were combined in the Learn video book. Graphics and programs were combined in the calculator. All of the computer's power is used to form a simple, responsive, and expressive medium. Our last example is a Boxer-based physics textbook with chapters on mechanics, optics, electromagnetism, and atomic structure. Here is a piece of the optics section of the book that contains a simulator for geometric optics. This part of the simulator contains a graphics box. Shown in the graphics box is a pointer that we can use to position mirrors and lenses. By running some simple commands, we can place a mirror in the box. We'll also add 2 lenses to make a simple optical system. To run a command, we can either type the command or select from a previously typed menu of commands. Remember that in Boxer, the user can always execute any command line that appears on the screen. Thus, to make a menu of commands, we need only type the command lines where we want them to appear and leave them on the screen for the user to select and run. Now we can shoot some light rays, and the simulator will show their path. Here we see a pencil of rays being reflected by the mirror and bent by the lenses. The simulator also has a view program that lets us see how a picture will be transformed by the optical system we just made. We can call up a graphics box that contains the picture we want to view. The picture will be placed here. Now we can run a command called look. This shoots a large number of rays toward the picture and keeps track of the path of each ray. The result for all the rays is reassembled in a new graphics box, which now contains a distorted image. This simulation also contains text which explains the various procedures that you can run and suggests optics experiments for you to perform. Notice that this text was simply typed in using Boxer's text editor. No programming was required to make the book, except for the programming in the simulations enclosed. We've seen how Boxer can be used to create a whole range of integrated environments. These range from personal information systems, like the journal, to programming systems, like the calculator, to learning environments, like the physics book, which combine text, programs, and graphics in new synergistic ways. Our goal in designing Boxer is to make these environments easy to use, easy to create, and easy to extend and adapt to one's own personal needs. We want to make this power available not only to programming specialists, but to everyone.